How does a steel tank get a glass lining?
What should be done in this emergency?
Which American artists work on the floor?
How can a shallow trench turn night into day?
Industry on Parade. Peabody Award winner for public service, produced on film each week by the National Association of Manufacturers.
At a Syracuse pharmaceutical house, Bristol Laboratories, penicillin and other drugs are produced under the most scrupulously antiseptic conditions possible. That even goes for the interiors of huge vats, tanks, pipes, pumps, and other apparatus. They're all lined with glass to prevent contamination. Fodler Company of Rochester is a firm which specializes in the manufacture of such glass-lined steel equipment, not only for pharmaceutical houses, but also for dairies, breweries, chemical factories, food processing plants, atomic energy centers, any type of installation in which the thing contained must not be affected by the container, or vice versa. Here, the parts are welded together. As you can see, demand for the specialized equipment produced by the firm is considerable. This is a process called swaging. They heat a part of the metal in which they intend to make an opening, then give the signal for a die-like tool to come down and force its way through the softened steel. Fittings are welded onto the opening, and then the welds will be ground. Meanwhile, glass for the linings is being made ready. The partly fused molten glass is chilled as it pours out of the smelter, causing it to solidify in tiny particles called frit, suitable for application to steel. Final conversion of the frit into the hard, smooth, chemically inert substance we know as glass occurs only after it has been sprayed onto the metal. But first, all welds are checked by X-ray and other methods to make sure they're sound all the way through. The radiographs would reveal any slight crack or imperfection. Now we're ready to apply the powdery frit to the interior of the tank. Hose lines carry air under pressure for the spraying, and the frit itself mixed with an adhesive which will hold it against the sides until heat fuses it permanently in place. Its interior completely coated, the 3,700-gallon tank now goes into a furnace, which is one of the largest of its kind in the world. There, temperatures of many hundreds of degrees, carefully controlled, will vitrify the frit and create an inner surface impervious to just about anything. At the end of the heating cycle, out comes the huge tank, already partially cooled, but still glowing. Before long, this vessel will be safely storing milk, producing salt vaccine, refining petroleum, or playing a role in the manufacture of some other essential liquid products in which maximum purity is absolutely essential.
Industry believes that one of the major requirements for the success of a free economy is that there must be a steady flow of investment capital, private capital provided out of the savings of individuals. With more than $12,000 of business assets behind every job in industry today, and with an increasing population requiring 1 million new jobs a year, we must prevent and eliminate interference with the basic processes of capital formation. These are the processes which make the new jobs possible. These are also the processes which raise the standard of living.
At a power station in Dayton, a battery of giant generators supplies electricity to an area of more than 6,000 square miles. Enough power to light homes, run factory machines, operate communication systems, and provide all the other services of electricity for more than 1 million customers. A wonderful thing, electricity, but it can be dangerous if it isn't handled with the proper precautions. For that reason, the Dayton Power and Light Company has on its staff a full-time safety supervisor who conducts a series of one-night safety courses for groups such as civil defense organizations and volunteer fire departments, like this one in Trotwood, Ohio. With the help of models, he points out that one of the major hazards, especially in rural areas, is fallen wires, wires knocked down by lightning, toppling trees, or traffic accidents involving power poles. By means of lectures and actual demonstrations, a safety course reveals the right and wrong ways to free a victim from contact with fallen wires. By means of a dry wooden pole that is either varnished or plain, never one that is painted, the wire is removed from the victim rather than the other way around. This is extremely hazardous, and the first thing to do in any such situation is notify the power company. If the victim is lying across the wire, it's safer to move him than try to move the wire. But it's of paramount importance not to come into contact with the victim. Non-metallic articles of clothing like a necktie or a belt with the buckle removed can be used to pull him free. To touch him would be as dangerous as to touch the wire itself. For our demonstration, an emergency truck from the power company arrives on the scene with its well-trained, well-equipped personnel. They find effective artificial respiration being administered. Their first step is to cut the wire high on the pole so that no one else will be endangered, after which they help apply first aid until the arrival of an ambulance. A dramatic demonstration of the fact that a fallen wire, like a gun, is always dangerous, for you never know when it's loaded.
Here's a technique that has made the installation of wooden flooring as simple as the laying of squares of linoleum. In fact, the techniques in both cases are the same. Just cover the underflooring with mastic and set the blocks neatly in place. In addition to easy installation, this type of beautiful flooring has become relatively inexpensive, thanks to manufacturing methods worked out at plants like that of the Mosaic Corporation in Louisville. Here we see a hardwood log softened by water and cleared of bark, about to be converted into hundreds of feet of thin veneer, multiplying by many times the amount of wood surfacing to be derived from it. Softer, less costly woods are also processed like this for use as the cores of laminated flooring blocks. The veneers are dried in preparation for lamination. A powerful synthetic resin glue is now applied to both sides of the core stock and to one side of the hardwood facing and backing, after which the 3-ply sandwiches are inserted into a press. Heat and pressure sets the glue and weds the poplar oak laminations permanently together. After emerging from the press, the plywood is run quickly through a water bath to restore lost moisture, and 48 hours later, after inspection, it's cut to size, then planed perfectly flat. The union of oak and poplar now has far greater strength and warp resistance than has either wood in an unlaminated state. After being cut to size, the blocks are fitted with tongues and grooves, which will let them interlock, one into another. Now another inspection among many. This one to check up on those tongues and grooves. The blocks then are sanded, graded, and matched for color. After that, the first of many coats of finish is applied. There's a wash coat, then a filler coat, which is rubbed smooth and uniform by hand. No machine has been invented to perform this operation satisfactorily. Next, a coat of lacquer. There's a trip through a drying oven, of course, after each application of finish. Now it's wax, laid on generously. And buffed mirror bright by machine. In addition to standard size blocks, the company also reproduces world-famous floor patterns designed for European castles or historic American homes such as Thomas Jefferson's Monticello. These are true mosaics in wood, and they grace many important buildings, up to and including the White House itself.
The number one health problem facing industry is the common cold. According to the U.S. Public Health Service, the toll from the common cold is over 150 million workdays lost annually, or more than all other work stoppages combined. However, industry, through the Common Cold Foundation, is doing something about this troublesome problem. Scientists believe that in the foreseeable future, a vaccine against at least one family of cold germs can be perfected. Through industry-supported research, the problem of the common cold appears nearer a solution than at any time in the past.
The airplane and the tractor, two symbols of the change that has come over American agriculture during the past quarter century. Symbols of the increased mechanization, mobility, and productivity that are the lot of today's modern farmer. The furrow dug here on the farm of Everett Horner will hold two wires to supply electricity for a lighting system which will outline Horner's landing strip and permit night flying. The lighting system came as a package, an install-it-yourself kit produced by the Line Material Company of Milwaukee, which also turns out the more powerful systems used at commercial and military airports all over the world. With lights hooked up 200 feet apart, the furrow is refilled. A rotating beacon, whose beams can be seen for 10 miles or more, is installed on a barn to guide the plane back to the farm. Ordinary house current is used for the entire system. An automatic time control will turn on the lights at dusk even if there's no one home. Mr. Horner's plane is more than a luxury. He operates 3 farms, which are scattered, and travels from one to the other by air. Also, in time of emergency, as when a member of the family was injured, the plane has been used to rush help to the farm. Now, even at night, the plane serves as a constant link between this isolated family and the outside world. The doctor arrives in minutes, and the situation is well in hand.